Can you see it? Can you see it? Yeah. Labguy here. This is another Watch Labguy work video. Probably medium length if we're all lucky. And it's the final physical assembly of the Eleanor, the installation of the control computer, the Arduino, and buttoning it all up finally and having a look at it. So enjoy. Alrighty then, it's the 30th of November 2020. It's 10:20 a.m. and we are resuming work on the 10.4 Eleanor. So put this aside so we don't scratch it up. It's beautiful. Place it out of the way. So I think what I want to work on first this morning is our back panel and get the jacks installed. That's not our boy. Come on. Or should I say girl? It's a female. Don't let the grand negas hear that. This is the male. This is the female. If you don't understand what I'm talking about, go ask your mommy and daddy. So, that will be our power input connector. The back of the Eleanor will contain a power input. It will contain the output jacks. What else should it contain? As far as I know, that's it. We need to make some holes in this panel, which looks really nice with the tape on it, but really it's an old circuit board. Alrighty then. Now our DIN connector will go there. Alrighty. I don't think it's the left and rightness is very critical. And 3/4. Bottoming out, I am. Ta-da! Alrighty. Can't be shy. And that's how quick that goes. Alright? I cannot recommend these enough. They're called step bits. I have to drill a total of 8 holes rather precisely for mounting the 6 RCA jacks for the red, green, and blue and Y output, leaving me 2 spare RCA jacks that I don't know what I'll use those for, if anything. Those would normally be your stereo audio. Be mounting this guy. And if you've seen the previous video, you remember the stencil. So we'll be using this stencil. That's why I drew the cross all the way out to the edges, so that we can see that. Notice there's a cross drawn on the stencil. That's all there is to it. You may not be able to see them, but there are 6 dimples in the tape now where we will be drilling. So I believe what we drill is small starter holes, drill bits. Those are right on the line. Just the way I like it. That should line up with that. Alright, this will be for our mounting holes. Our number 4 mounting screws. Brutal, ain't it? I did mention I need work gloves. Now does it fit? Hey, look at that. Oh, look at that, huh? Like a glove. I took the back panel outside and painted it. It's currently drying and it's a cold day, so it's probably going to take the rest of the day. So let's return to this guy. Yep. There's our +5, +12, -12 off-on switch. It's a triple single pole double throw, I believe is how you say it. Double pole single throw. So we have that and this. So we have our toggle switch and our rotary encoder. And what I want to do is mount them left and right of our display, and I want them centered. I want them centered this way on the display and centered this way between the end of the display and the edge of the panel on both sides. Three-quarters of an inch from the edge of the display out. There. And there. $246. Okay. So a 250 ought to do the trick. .269. He's 270 mils. He's bigger than a 1/4 inch. This bit measures 280 mils, or 280 thousandths of an inch. Alright, our rotary encoder should go in. Nice. Now, our encoder is also equipped with a pin, anti-rotation pin, which I suppose I need to drill a tiny hole for that. Alright. Perfect. Washers. Oh, look at that. It's the anti-rotation washer I needed. Oh, goody. Very good. So we have the switch. It's on the right side. We have the rotary encoder. We want these loose so that they can move. These. And that's so that when we place this on, they will move where they're needed. And then I take and I press on the display to hold the spacer in place and tighten the screws. And that positions the spacer for the display. Boy, I got that display nice and flat to the surface there. Those spacers are perfect. This is. Snug them down. And that display is going nowhere. Okay, the display, the off-on switch, and the rotary encoder are now installed on our front panel, which has a nice low profile behind the panel. What's that? It needs a knob, you say? You are correct. It does need a knob. No? Oh well, this one's good. It keeps your fingers up away from the panel, so keep fingerprints to a minimum. The toggle switch is okay. Alright, our front panel is getting there. Our back panel is still drying. And I'm pretty sure it's just as wet as when I spray painted it an hour ago. There you go. All right. And we even have the front panel screws. Alrighty, so I bet the fellow who drilled the 6 ugly holes in that, who knows how many years ago, could have been as long as 20 or 30 years ago, did not think that his finished unit could look so good. That looks great. This just turns. It's a rotary encoder, so it's arbitrary. I'll get an unmarked smaller knob for that. But for the moment, I like the fact that it keeps my fingers up off the metal. The off-on switch. Now I'm going to either paint the metal, or if I can keep it unscratched like it is up to the end, I'll spray it with clear coat. There's our innards, and our power switch is on the same side of the panel as the DC input, so that we can so that the wiring goes straight across. We don't end up with crisscrossed wiring, although this has to wire, yeah, it has to wire crosswise. The Arduino will sit on this side, and the Eleanor board is on this side. So there you go. Sweet! Just like Mother used to build. Well, the paint is dry on the circuit board, and oh my God. Look at how nice that came out. I got the holes dead on for the video jacks. These are always relatively easy to mount, but they're nice and straight. They're proportionally spaced. And the paint job looks good. It's just amazing. Let's look at the inside. That's the back side. You can still see that it used to be a circuit board. Here's the video jacks, clearly, and the DIN connector. So with the paint job, this thing came out great. I painted it this morning. It's after 3 o'clock now. It sat in the sun for a while, and then I brought it in while it was still drying and set it on top of my electric heater to kind of bake it to a finish. And I have to admit, I'm very pleased by that. That is very good. So, moving right along, the next step will be to wire everything up. Stand by. Well, before I start, I will of course have to wet the sponge. I like to use this extremely dangerous liquid we have on our planet called dihydrogen oxide. It's an excellent solvent, but it is deadly. It kills thousands of people every year when they fall in it and drown. Sure is getting hot. I think it's got a heat sink. There it comes. Oh, there it is. Oh, there it is. Alrighty then. Yeah, the old wires don't hurt anything. We can remove them. Okay. There we go. This one may, in fact, is perfect. Okay. Oh, I see. It's one wire. There we go. Alrighty then. That's cut off. Alright, we've got our bird pins, DuPont pins, whatever you want to call them. We're going to be adding just one pin. I don't know if you can see it. One pin to our connector. That is right here. There we go. Now that will hold our pin in place while we solder him down. Gee, Labguy, you're kind of clever. Thanks. Here's our big capacitor. Probably can't see it. It's going to go right there. That's 100 nanofarad, 0.1 microfarad. And we're going to go ahead and ground him now. That's to block high frequency noise that might come in from the outside world, coming in from the power supply. Like that. Okay, so the new pin is in. We now have a 4-pin connector. It's somewhere right there. And I need to move the LED. This LED right here. And remove these two strip LEDs. They're obsolete now. As I think about it, I'm not going to take out the LEDs because there's no need to. They aren't hurting anything sitting there. I don't need the circuit board space, but I don't want them sucking up power and lighting up the inside of the box, by the way. Don't need light shining out around the seams. Yeah, I guess I'll let you see the mistake, but it's fixed. Now it's on the correct side and the wrong side in the viewfinder. And of course we're all wobbly because we're missing a foot. Now there's a joke in there if you watch the movie The Big Bus. If you know what the joke is, when I said it was missing a foot, leave it in the comments below. Dan Torrance. Yeah, Dan Torrance. I remember Dan Torrance, Mount Diablo. Dan Torrance. Yeah. Hey, this is nuts. Yes, it is. It is nuts. Nuts. I'm having a good time. I think I'm hungry. My food is cooling. Okay, that board is in place. We are part way there. We got to do essentially the same thing with our Arduino, and I need to leave him back enough room so that we can plug in during the maintenance phase of this project. The rear panel will be lifted up so that the USB connector can come in beneath it and plug into the Arduino. If I'd been more clever, I might have lined it up with the back panel and made an opening for the USB, but I didn't. Oh my. Boy, that just, oh my goodness. It's upside down. That's okay. This has to come out and flip over. No problem. Okay. Well, at least the connectors reach. I was worried that this jumper wire on these rear panel video jacks wasn't going to reach. It's not only is it going to reach, it may be too close. I don't know yet. We'll see. All right. Groovy, man. At any rate, the Arduino is mounted. Resuming construction at 10:20 a.m. on December 1st, 2020. Work on the 10.4 Eleanor continues. As you can see, there has been some wiring work right here. I've wired the power connector to the power switch and back to a terminal strip, antique style terminal strip, which is now wired up as plus 5 volts, ground plus 12 volts, and minus 12 volts. So along the way I confused myself and used green wire for my minus 12 volts. No big deal. Green is usually my internal house color code for minus 5 volts. But since there is no minus 5 volts in this project, it's not a problem. So we're resuming construction at this point. I will next have to create a power lead for the Eleanor board. I have to take the Eleanor board out and install a 3-pin header for the I2C connections for the parallel port. So that is where that is at, and then after that I have to make wiring harness from the LCD display to the Arduino, and from the rotary encoder to the Arduino, and then the physical hardware will be complete and programming of the Arduino can begin. That's the last phase. So remarkably, I had installed the Arduino and the display on a breadboard in the very beginning of this project, if you recall. And had connected the Arduino and the display and had the display showing content. And you know, I never drew a schematic of those connections, so I have to go back and rediscover how I had it hooked up. It's not too difficult. The display is just a 4-wire connection of ground, VCC, serial data, and serial clock for the I2C bus. And I never wired the rotary encoder, so its wiring is still arbitrary. I'll get that from some YouTube videos. And I believe the channel I got that from was called DroneBot Workshop. So if you're working with Arduinos and interfacing them, DroneBot Workshop is the channel. Hello to the webmaster of DroneBot Workshop. I don't know your name. Moving right along, I guess I'll dig up a 4-pin connector for the power plug on the Eleanor board. So we'll do the green first. I think, yes. Plus 12 is connected, ground is next. Alright. Power is connected to the Eleanor board. Right here. Everything plugs in and unplugs nicely. We have a 3-pin connector that has to go right here, right there. So I have to take the board out and put the 3 pins in for that, wire them up. Putting in the I2C connector now for the frame selector port. (14) and 15 are my I2C pins. I'm installing 0603 size 10K pull-up resistors, the I2C lines. It's connected now. Alright, our I2C interface is right there. It's data, clock, ground. There we go. Let's mark those before I bolt the board down and can't remember which way they go. Let me solder it in place. Why not? Huh, what do you know? Okay, that one's in. We'll use green. Well, somewhere in that length, the white and gray wire, that's the SDA and SCL. Ground is over here, so I'm going to splice these 3 wires into these wires. So that's how those will be connected. As you can see, it's well underway. It's 10 after 2 p.m. December 1st, 2020. I'm going to hardwire the leads to the rotary encoder, and I will probably end up hardwiring the leads to the display, as well as changing these plug-in pins to pin strips, where I can plug multiple pins into this header, and it'll have a better grip and is less likely to be accidentally pulled out while we're trying to dress the wiring. So that's where that's all headed. I want red and black on the 5 volts and ground. So fortunately, I have a second encoder, because all the labeling is on the side with the encoder, instead of the side that you would see when the thing is mounted in a panel. Hello, whoever designed this thing? Good job. Print the signal names on the back, please. You probably have noticed that I always tin all my wires before I solder them to anything. This just makes this, ultimately, the soldering so much easier. Just like that. Next, okay, let's flip that over the back like that. Use the tweezers so that I don't block your view. I believe that's connected. The next one is the switch. And that's the brown wire. And then the next signal is called DT. And finally clock, so I'm making DT the orange wire. And clock is the yellow wire. There we go. They are now connected. Yes. To run these wires behind here.
like that,
so that they exit on the same side of the display as the wires for the display itself. And well, we want it to bend that way, so I'll put a bias in it so that it bends this way. And you see it exits down here by the comes on down to the pins where it's going to connect to the Arduino. And if I'm not mistaken, it's all wired. Everything is connected. Okay, look at that. Oh, that looks like a power supply cable, Labguy. Doesn't it, though? At this phase of the project, it's called No Guts, No Glory. I'm going to turn off the light. And she's either going to smoke or she's going to light up and say something meaningful. What do you think? Place your bets. Place your bets. Okay. There we go. Switch is off. What do you think? Will it light up and say something? There's no code for actually running the Eleanor board, but the menu was already done. So let's see if it smokes. Can you see it? Can you see it? Yeah. We have a functioning unit ready for programming. You saw it here first on Labguy's World. Woohoo! Let's talk about the power supply I'm going to use very briefly here. I bought this one originally, which is made by Acopian. I call these epoxy bricks. This thing is hefty, and it's a very good power supply. It's environment proof, I presume. And the fellow who was selling this on eBay had it mislisted on its specs. He said that it was 120 volts AC in, which it is, and plus and minus 12 volts out, which it is. But he said that he listed as 1 amp power supply, and unfortunately it's good for 100 milliamps on the plus 12 and 100 milliamps on the minus 12. That's okay. I mean, that's not a very powerful power supply. That's what, 1.2 watts, 2.5 watts roughly power supply. So this would have been an ideal power supply. I was thinking it would fit inside this case, but we know it wouldn't, but that was the plan. So then I purchased this one. It's a Meanwell switching power supply, model GP25A13D-R1B. I got this on eBay for about $35, and it's rated at plus 5 volts, I think, 2.5 amps. 2.5 amps at 5 volts. So that's 15 watts, isn't it? I think so. 12.5 watts, something like that. Minus 12 volts, 300 milliamps, and plus 12 volts at 1 amp. That's a lot of power. That's a very powerful power supply. About 25 watt power supply. It's very nice and it's compact compared to the one I'm going to use, which is the Globetech power supply, TR2V1000N00. I got 2 of these on eBay for about $30, and it's rated at plus 5 volts at 1 amp, plus 12 volts at 300 milliamps, and minus 12 volts at 300 milliamps. And apparently it's meeting our needs, but it's hefty. This is a murder weapon, which is good to know. In case I need to defend myself, this is the one I'll grab. So anyways, this power supply and the Meanwell both have the 5-pin DIN plug, and by good fortune they're pinned out identical. I could plug this power supply into the Eleanor and it would work, but 5 volts at 2.5 amps, this thing draws less than 100 milliamps on the 5 volts, so no. No. I'm saving this for a bigger project. So this is our power supply. It's a linear, and that's the one we will use. So at this point, the Eleanor is physically finished. I'm going to have to rearrange my desk in order to set this thing up to route the USB cable to the inside, because as you can see, I made no provision to get the USB to the Arduino on the inside. The USB on the Arduino is right here. So to do that, I'm going to have to lift this up and physically lift up the back panel so that the USB can come in under here. And this is about what the programming position would look like with the USB cable. So not pretty, and I'll have to hook up the CRT televisor to it in order to see when I get the I2C port working correctly, working with the button. I figured out why the display would go blank when I would rotate it, and it's because it's configured for interrupt operation right now. I had started writing the code, and so the interrupt is enabled, but there's no interrupt routine, so the Arduino ends up resetting. No big deal. That's what happens when you run incomplete software. So at any rate, we are at the Arduino programming phase of this unit. The insides are gorgeous. I'm very, very happy with how this has come out to this point. As you can see, it's quite the project. I suppose you can leave it in the comments. I'd like to know what you think. I really want to paint the aluminum panel with clear coat, clean off the fingerprints, because boy, you touch it and you got a fingerprint. And I went to the store today. They didn't have any clear coat, not at the store I went to. They did have flat black, which I use on all my projects, on a lot of my projects. And I was thinking I could paint it flat black, but I think this color scheme is the best. I like it. It's kind of industrial looking. No decals or anything. All of the information will be on the display itself. And I'm going to probably clear coat it. So what I'm getting at is my options are to clear coat this as aluminum or paint the aluminum flat black. So if you have an opinion on that, leave it in the comments below. And this completes the assembly phase of the 10.4 Eleanor. And I will probably document the programming phase, but the next time you see this in the following video, it should be fully operational at that point, and that will be the introduction into the hardware deep dive, where I will finally reveal the schematics, and we will talk about how the Eleanor video circuits work. And for those of you who wish to make copies of it, I'll give you links to the project page, and where you can get the full schematics, and you'll be able to download the at least my initial binary files for the ROM chips if you're interested in that, and that will jumpstart you. And I'll also provide the source codes for the basic programs that I wrote, and you can get the QB64 for free and download that and install it, and be able to modify the timing ROM and the image ROMs yourself and program them yourself. Put pictures of your grandma or your dog or pictures of flowers, whatever you want to put in it. It has 256 picture locations. So as I said, this is the completion of the hardware assembly, and should be the end of these hideously long watch Labguy work videos. So until next time, Labguy out.